Okay.
That's not good. Wait, I got 2 over X.
Yes. Um, Most people, but if I can't remember if I started getting some out and got interrupted. Are you listening? You only got one. I'll make sure you're not missing anything for a second. Okay. Did you get that the numerator for the x squared is 1? Did you get the numerator for the x minus 1 is negative 1? Okay. And then altogether, the x squareds on the left, there's 1x squared on the left, and that would equal a plus c x squareds on the right, yeah? So 1 equals a plus c, 1 equals a minus 1, so a is 2. The numerator for the x is 2, yes? Okay, so the new problem becomes 2 over x plus 1 over x squared minus 1 over x minus 1. Do you agree with the new integral? Okay, do you agree with the antiderivative of 2 natural log of the absolute value of x?
I agree.
Do you agree with negative 1 over x for the antiderivative of that? Power rule minus log of x minus 1. All right, cool, proceed. All right, this lesson is pretty straightforward. It will go fine if you just pay attention. And quite frankly, even if you don't pay attention, you'll still probably get it, but pay attention anyway. Here we go. There's really 3 middle ideas, but actually 3 ideas, one of which is a huge idea of series that's super easy to apply. Goes a little like this. We talked about this. You've been adding series and trying to find an infinite sum of infinitely many terms, yeah? Now the only way you can get a sum for infinitely many terms is if the terms decay to 0. If you get terms that are big or even just like 1, you couldn't add infinitely many ones and get a finite sum. Do you agree?
Yes.
That is the divergence theorem. If also, would you write in here, also called the nth term test. Some books call it, more books call it the nth term test, really. Our book calls it the divergence theorem. And it goes like this. Before you even try and find an infinite summation, you say, is there even a chance? And by even a chance, that means, do the terms go to 0? If you take the limit of the terms, now that's the terms, not the sum. If you take the limit of the terms, and the terms don't go to 0, it's done. It has no chance of divergence, period. Okay? If the terms do go to 0, it might converge. It has a chance of converging, and then later we'll proceed on with further tests to see if it does or not. Okay, so right now it's the great dividing line is, do the terms go to 0? And if the answer is no, then you're done. Diverge. And if the terms do go to 0, then it might converge, and we'll go more later. So let me give you an example or two. If you took what happens to these terms, and you can rewrite this, or you could just call it a sub n if you like. If you took the limit of the terms, do those terms go to 0 or not? Using n behavior. You do not have to do L'Hopital here. Is that clear?
Yeah.
Okay, use n behavior. So the terms go to infinity. Why? Yeah, the exponential wins in the competition between linear and exponential, so it goes to infinity. Therefore, we would conclude that series diverges. The sum of all those terms will get infinitely large because the terms themselves get infinitely large. Cool? What is the limit of the terms here? I heard somebody say 2/13. Now that's great. And if they asked, does this sequence converge, you would say, yeah, the terms converge to 2/13. But the question isn't, do the terms converge? The question is the infinite sum. If you add infinitely many 2/13, doesn't that still get infinitely big? And so because that's not zero, sorry, I should say that's the test. The series diverges. Okay. Do you get so do the rest. I don't know if you read the instructions here, but you don't have to show L'Hopital. If it's geometric, you could use geometric knowledge instead of the divergence theorem. But for each of these, tell me if it converges or diverges, or might converge or diverge based on do the terms go to zero or not. Okay? Oops. That one's a bit of a stinker because it doesn't have a limit, yeah? So I would just say that it does not equal zero. I was about to say plus or minus 1, but that's not even true. It's cosine of 1, cosine of 2. Those are all crazy weird things, right? They're not even clean. So I just said the limit's not zero, so it right? Or not yet. Okay? Okay. So for the cosine, we said the terms do not go to zero, so it diverges. This guy, this is actually called the P series, and there is a criteria for that we'll talk about later. Did you agree that terms do decrease to zero? So does that mean it converges? It may. It should be might converge, not converge. You don't know if it converges yet. It's might converge. That fifth one, you could go one of two ways. Because it's geometric, you could either go geometric or the way you have been. If you just looked at the terms, do the terms approach zero? Yes, so you would conclude might converge based on the nth term test. If you did it in a geometric way, you would say, hey, it's geometric. The absolute value of r is the absolute value of 2/3, which is less than 1, so it does converge. It doesn't, however, say you want to find the sum. Okay? And the last one. Did you say converge or diverge? Diverge. What's the limit of the terms? What do they approach? E. Okay. So doesn't that mean it converges? It converges to E. No, the sequence converges to E, but the series diverges because you're adding infinitely many close to e's. That gets infinitely large. So it is not 0, so it diverges. And by it, I mean the series diverges. You follow? Second idea, arithmetic of series. This is part of all levels of calculus. You learn rules for dealing with limits. Can you add them? Can you separate them? You do limits, rules of integrals and derivatives. Same with rules for series. There are rules for series. Can you separate a sum? Can you separate a product? Cha-cha-cha. It is true that if you get a series that adds two different functions, you can separate them into two series and then add them. Now, that makes a lot of sense because if you were to expand this, it would be A1 plus B1 plus A2 plus B2, cha-cha-cha. That's what that left side would expand to, yeah? The right side would be A1 plus A2 plus A3, cha-cha-cha, and B1 plus B2 plus B3, cha-cha-cha. Well, couldn't I rearrange that and put the A1s and B1s together and the A2s and B2s together by the associative or commutative property, sorry. And so it is true that if you have the sum of two series, you can split them into two separate series, which we'll do in a minute. For example, for this, we would split it into two series rather than deal with it like one big old mess. You can split a sum into two, just like an integral, all right? Also, just like an integral, you cannot split a product into two separate products. If, for example, I wanted to show this is not true, this should be A1B1 plus A2B2 plus A3B3, etc. on the left. You see? Okay? On the right, we're talking more like the infinite series A sub n, which is A1 plus A2 plus A3, and then times B1 plus B2 plus B3. Now, if you look at the right, there's a lot more going on. If I were to clean up the right side, I wouldn't just get A1B1. I'd get A1B1 and A1B2 and A1B3. And obviously then it is nothing like the left side. It's way more complicated. Those are definitely not equal. So if you get a sum in a series, you can split it, a lot like an integral. If you get a product in a series, you cannot split it. You must keep it together. All right? That said, then here's some rules for dealing with series. Say you had one series that converges, and say I told you that the sum of that series was A, capital A. That's what the sum approached. If I gave you a different series B and it converged to B, then the sum of those two would converge to A plus B. Easy enough. If one of the series converged to A, but the other diverged, well, then you're adding finite to infinite, and the result is infinite. And so if one of them diverges, then the combination will diverge as well. If you said one converged, and then you added a constant or multiplied by a constant, then it is nothing but C, that constant plus the sum, or that constant times the sum. You can factor constants out front of a series. That is fine. If, for example, you had 3 times 1/2 to the n, you could definitely put the 3 out front and just focus on the series. So factoring a constant out front, a lot like an integral again, is allowed. If you had a series that diverged and you had a constant, then the sum of that constant and the series would diverge. Assuming C is not 0, then that would also diverge. If it were 0, then you're talking an indeterminate form that's a bit of a mess and we don't usually get into it. And last but not least, if This is an indeterminate. Sorry, that's the indeterminate form. I guess I didn't read all the way through. Okay. Now, actually, that's not an indeterminate form. That's stupid. Why isn't it an indeterminate form? Because C isn't approaching 0. It is 0. So you're talking about 0 times this, which is 0 forever. So that's not indeterminate. Sorry. It's 0 because it's not about approaching 0. It is 0. Period. My bad. Sorry about that. All right. Now, if we use those rules a little bit in some doozies, you'll see how that can help you out. This guy, for example, if you were asked, the question is, does this converge or diverge? Am I in the right place note-wise? Are we good? Okay. The first thing I would do is split this into two separate problems. E to the n over pi to the n, and 4 over n minus 2 to the pi over n. You see? All right. Now then, we could do each of these separately. Does this first one converge or diverge? Converge, justify. Okay. So are you using end behavior or geometric? All right, by end behavior, the limit as n goes to infinity is 0, so it might converge. If you were to do this geometrically, what's r? E over pi, and is that less than 1? It is, and so if you went geometric, you wouldn't even have to say might converge. You could say it does converge. All right, the second though, however, first thing that I see is the index is kind of funky, yeah? Can you make this a little better by a little cleanup so that they're both to the end? How could you tweak this a little? How could you rewrite the 4 so it's nice? 4 to the n and 4 to the negative 2. Now that's a little more easy to decide geometric or end behavior, whatever you prefer. But does that converge or diverge? That diverges. Let's do this geometrically because it's a geometric with a common ratio of 4 over pi, which is not less than 1. And so what do we decide on the whole? Might converge plus diverge is diverge. Okay. All right. Also, the book is going to, kind of like we just talked about, the book is going to ask you to sometimes change the series a little bit. There are times where you want it desperately to start at 1 rather than at 3, for example, in this case they're giving you. So you'll have to find an equivalent by changing that a little bit. There's two ways that this is done. Some people can just look at this and say the top needs to be 4 to the n. Okay? All right, so maybe we'll get to the quick way in a second. But let's first, if you're not sure, it might help you to make a few terms. For example, when n equals 3 goes in, what do you get? 4 to the 5th over 3 minus 1. Don't oversimplify. 3 minus 1. Okay? All right. So that means if it starts at 1, then we need this to be 4 to the... Okay, so you need to have some rule here, right? N something. And you want it to make a 5, and 1's going in. So it needs to be n plus 4. Okay? Check to verify, does that make sense that if n equals 1 goes in, you get 4 to the 5th? Yes, all right? Now what about the denominator? over n. Let's check to see if it works. If you put in a 1, you get out a, okay. Actually, maybe it doesn't hurt to call this 2 instead of 3 minus 1. I was thinking it would help to see the pattern, but it doesn't. Okay, n minus 1, n plus 1, what? N plus 1. Check, does that work when n equals 1 goes in? Do you have 2? And the answer is yeah, right? So it feels like in terms of looking for patterns, in going this way, we needed to add 2 to the n. And so this was 2 more than it originally was, and this is 2 more than it originally was. The best way to me is just to make a term and verify your rule works, right? And just from past experience, a lot of common misconceptions. Would you do those true or false questions? And we'll talk about them in a minute. Tends to 0 is the same as the limit of the terms to 0. True, by the way, means always true, not necessarily.
So if I can
Must
find
be,
a case
must
that's
be.
not true, then it is false.
What?
If you find a case.
Exactly, yes. Proving a logic to prove something is not true, all you need is one counter. But to prove something is true, you need to prove all cases are true. That's rough.
Like say you're correct, one half, you say like 1/4 plus 1/3, or 1/4 plus 1/2, you can say that's false, true, false, false, true. Oh, there's one after that? Yeah, I'm pretty sure. I'm on.
¿Listos?
I said the n before, I said that's false. No, but I said that as the series. Or that is the.
Yes? Yes. We will look over the test. All right, here we go. Speaking of that, let's get moving. So the first one, true or false? Everybody at the same time? False. That is correct. What? Why is that false? Oh, I was looking at the wrong one. Okay. So this is false, you say. All right, that's true. If the terms tend to 0, that doesn't mean the sum tends to 0. That's ridiculous. What about if the series converges, then the terms must have had a limit of 0? That is true. Okay? The nth partial sum of the series is a sub n. False. A sub n represents terms. What do you use for sum? S sub n. S sub n represents the partial sum. Okay? If the limit of the partial sums is 4, then the series must diverge. False. If there's a limit to the partial sums, then the series converges, and therefore that must be false. If the terms tend to 0, then the series must converge. That's not necessarily true. which is to say false. Okay? It could converge, not must converge, or always converge. All right, and if the partial sum decomposition lends to that, then is it true that the nth term is 1 over n plus 1? It is not true. It is
That's the then would that be true though?
not true. What is the nth term?
Yeah. It's that.
There's an nth term. That's not the same. What are they saying? That's the,
That's the sum. That's
this is the partial sum point. S of n is 1 minus 1 over n plus 1. And the limit of the partial sums is 1. Okay? Alrighty. Boom. Good deal. Test time. Test time.
Oh no.
Put away your phones, please. This is the one from last Thursday that was disastrously copied and passed.
Yeah, I was going to ask about this.
So it's really all over the place, depending on your version, you might have different backs, other people. Yep. So why don't you just do it?
I got a point off on some. Oh, that's. Oh, my computer didn't like That's very disastrous.
Okay, overall, I was super happy with the results, strong results on all the questions that were the same as previous years. You did as well or better than previous years. So overall, I'm really happy with where this class is. A couple things, just even if you didn't miss them, just by way of learning from other people's mistakes. This one went really well. One was for the substitution, one was for the cleanup, one was for the antiderivative, and one was for the answer. So that was the hierarchy of points, and the minute you made a mistake, you were kind of out. I didn't want to get into, well, is this kid's new integral easier than this? The minute you cleaned up wrong, then you were done. Okay? This was indeterminate form. It was the square root of e, and that was really well done. I was happy there. Most people did the length of the curve just fine. Not much to say there. Vertical. A tangent is vertical when there is undefined slope. In other words, rise but no run. So 0 in the denominator. So you really needed to set dx dt equal to 0. If you forgot how to find vertical slope, write yourself a note. 0 in the denominator of the slope. Okay? This, you definitely had to clean this equation up first before you try and identify k. K was 300s, not 3. And L was 200. Most people did the equation right. The equation was 4 points. One for just basically having the right population form, e to the negative something. One was for L, one was for B, and one for K. Population is growing most rapidly when the population is half the carrying capacity. That was part one. And then finding the time was part two. One of the most missed questions on the test was people, I felt I cut you a little slack here. When I say what's the limit, I mean for this problem specifically, what's the number? Not, oh, it's 1/2 of L, or what's the number? Give me the freaking number, all right? Not 1/2 of L. I just forgot about that. This guy. Okay, there are two things that you can learn from your colleagues on that they might have made a mistake on, even if you dropped a 9, which was the mode. I'm not giddy with joy. I'm happy because the mode was a 9, but the median was not a 9, which implies that I'm looking for a more mathy thing. If the median is 9, then at least half the people got a 9. Okay? We would like to get to the place where the mean, median, and mode are all 9. And if the mean is 9, then everybody gets a 9. That's where we like to get to. Let's start here. A was fine. A went well. There were some overachievers in the crowd that said, I don't care if you said you can use a calculator. I don't do it without a calculator. Good for you. Good job. No extra points. B. B, there's, learn from your peers, please. B. B, the most common error on B was run on mathematics. It said to first find the volume, and the volume was pi over 8 times the function squared dx, yeah, from 0 to 30. Do you agree that finds the volume? All right. People found that. Can somebody give me that number, please? 2000? 56.194. All right. All right, now here's where they lost their point. They gave their point back. They said, okay, but now I need to find the chocolate. And they said, okay, so now I multiply that by 0.0. You just ran one thought into the other. That's bad math. You are just like my pre-algebra students that when they're given this problem, they say, okay, so 5 plus 3 is 8, plus 2 is 10, minus 4 is 6. So they basically just told me that 5 plus 3 is 6. That is terrible math, to run one idea into the other. Draw a period, separate it, and do the next thought in another step. This is not true. It's not true. This is not equal to that now. The minute you wrote that, do not run one idea to the other. Ooh, bad math. Okay? C. Okay, stick with me now. I'm going to teach you pre-algebra perimeter. Perimeter is when you put your little finger on the curve and you go all the way around. And when you go all the way around, you also add a 30. So congratulations, you know calculus, you know arc length, but you don't understand perimeter. Ay, ay, ay. All right. This went great. This went great. This was the most missed question on the test. Just step back and think, okay? Tell me what solutions you can dump right away. What multiple choices are gone before you even do the calculus? BCB. Gone. Because you know this is a circle, and at 4, 3, it is definitely concave down. There's no way, no way, no way. All right? Now, after that, if you made a mistake, most often it was a mistake in the arithmetic, ironically, not the calculus. That was 1 point for the first derivative, I think. No, 2 points for the second derivative, including 1 point for the chain rule within adding the dy dx in, and then 1 point for the answer. This went fine. This, some of you are a little rusty on this guy. How your method is up to you, but this is what I did. If I look at signs, this is positive here, negative, positive, negative. This is not positive slopes in that quadrant, so that one's out. This, those are even. This was the most missed or chosen distractor. That one that to me is the most unlikely. Every one of those is even. That should imply that every slope you see is positive, is it? Certainly not. That cannot be it. Why would you choose that one? I don't get that. Okay? This works out to be the same size as that one, so it's that, so it's out. X squared y is positive over positive there, positive over positive there, positive over negative, and positive over positive. Is that it? No, that was it. And so is this one. Okay? Use signs. Use signs. And then the last couple. This was actually, depending on your version, this might have been n or n plus 1. Most people did that great. For this one, you had to divide. That was 2 points. Partial fractions, 2 points. And then integrate 1 point, maybe? 2 points? I can't remember. And then the last one. Gosh, I was really happy with how this went. You guys did really nicely. It was 7 points. 1 point for the differential equation. 1 point for the separation of variables. 1 point for the partial fractions. 1 point for the integration. 1 point for eventually getting to plus or minus e to the c. 1 point for using the initial condition of time equals 0, a equal a initial, or p equal p initial rather. And then 1 more point for the final cleanup, which was a lot to get to the final result. All right. Overall, I was really happy. Overall, then the test went great. I was very happy with it. If you didn't do as well as you like, please come in and we can talk about it individually. But I need that back. Thank you. If I made a mistake, by the way, please let me know. So you had one of the versions where the wrong back was with the wrong foot. So this should have come with this one should have come with this. These should start. I will check over. No, I don't think that's a curtain necessary. I got a lot of people stay up late. No, I'm really good.
Wait, well, listen to this.
I don't know.
That's my argument.
Oh, you're right.
What was the total, average result? Was it an A?
So,
And I circled the wrong answer, what? And I did really
I can't exactly trust the totals because some of you have the wrong back with the wrong front, so that's why you feel like you might feel like the totals are wrong. No, no correct. You think? I feel like if the range is a C, then it's a square test. If the median is at C. All right. Questions on set 120? What? 1? 19? Curves are for the week. 21. Okay. Oh. Okay. All right. One. Oh, yeah. Okay. I have no answer. All right. Okay, so okay, so this is logistic growth. All right, so we know that the equation should be logistic, okay? Okay. Can you tell me anything? L is? 50, okay. That's cool, so we can put that there and there. Cool. Hi. Oh, sorry, I didn't even know you there. Are we cool there? And then, what about the B? B is L minus P naught over P naught, okay?
Yeah.
So that's 50 minus 12 over 12. So you get 38 twelfths or 19/6. Okay? So B is 19/6. What about K? We need another case to find K, okay? So let's plug in the case of P at 1 is 18. So 18 equals 50 over 1 plus 19/6 e to the negative 50k times 1. Sweet. Okay, if I move that over there and divide that over there, then subtract 1, I get that 19/6 e to the negative 50k is 50/18 minus 1. Okay? Okay, so e to the negative 50k is 38/18 times 6/19. See? Okay? Which equals 2/3. That's nice. So K is log of 2/3 divided by negative 50. With that then, and you can say the population would be 30 when your equation equals 30. And I would definitely store your K. And you're going to solve that for 2. Okay? So that would be something like 5/3 minus 1, 5/3, 2/3. What? Which part?
Oh, no, I'm just
Oh, okay.
questioning my.
So solve that. Does anybody have an answer to that that did all this?
Yeah, 2.557.
We all agree? All right, I have faith in you, Eric, that that's correct. All right, 19, question on 19. 19 was rough. Oh no. Oh man, another day, bye. What was 19? Can I help you? 19, I would definitely do an in-depth integral, then evaluate. So don't do the balance. Find the antiderivative without. And you don't have to, then you would say, so you do that off to the side, and then you'd say, so this then is. With me? Yeah, that's the best way to deal with it. I definitely would work on the large scale.
Thank you, Mr.
You're welcome, have a good day. Yeah. How far off are you? You're to like 1,000? Have a good day. Recording.